Today's paper is RetrieveGAN, Image Synthesis via Differentiable Patch Retrieval. The method proposes a scene image generation model that takes as input a scene graph description and learns to select mutually compatible image patches through differentiable retrieval process and synthesize the output image from the retrieved patches. The previous limitation of scene generation process from scene descriptions are as follows. Existing models require predefined embeddings of scene descriptions, and it was not possible to differentiate the retrieval process. Also, multiple objects should be retrieved given a scene description, but conventional retrieval process selects each image patch independently, resulting to a weak relationship between retrieved objects. The authors of the paper makes three contributions. First, they propose a novel semi-parametric model to synthesize images from the scene description. They then demonstrate the usefulness of the differentiable retrieval module in capturing the relationship among the objects in an image. Lastly, through extensive qualitative and quantitative experiments, the authors show the efficiency of the proposed method. The figure shows the framework of the RetrieveGAN model. It's composed of three stages: scene graph encoding, patch retrieval, and image generation. Scene graph encoding module takes scene graph as an input, extracts the features, and predicts bounding box coordinates for each object in the graph. Given the box coordinates of each object, the patch retrieval module retrieves an image patch for each object from the image patch bank. The objective of the retrieval module is to maximize the compatibility of the retrieved patches and improve the quality of the synthesized image by the subsequent image generation module. Lastly, the image generation module takes retrieved image patches and bounding boxes as an input and generates final synthetic image. The goal of the scene graph encoding module is to provide necessary information for the patch retrieval and image generation modules. It does this by constructing a scene graph encoder with a series of graph convolutional networks and predicts bounding boxes of each object in the graph input. Because there are a large number of image patches in the patch bank, the module first pre-filters k number of candidate patches. This enables the module to retrieve object patches on a subset of image patches, and this solves memory limitation problem. In the patch retrieval process, given the candidate patches m, the module uses Gumbel-Max trick to sample a single patch, and this process is performed iteratively to select compatible patches for all the objects. As shown in the figure, at each iterative process, given the query feature f and previously selected patches, the most compatible patch p is selected. The proposed architecture is differentiable, thus it enables training the retrieval process, maximizing the mutual compatibility of the selected patches. For more details of the process, I suggest reading the paper in detail. The image generation module is similar to the PasteGAN model. The generator takes input as box predictions and retrieved image patches, and produces synthesized image where its realism is again determined by the discriminators. The module uses two discriminators. Image discriminator determines realness of the sample on the image level, and the object discriminator determines the realness of the image sample on the object level. The table shows evaluation of the model on COCO stuff and visual genome datasets. Used evaluation metrics are freshet inception distance, inception score, and diversity score metrics. Note that the RetrieveGAN model has similar performance in both settings on the COCO stuff dataset, but has significant improvement using ground truth bounding boxes on the visual genome dataset. The authors state that the reason for the inferior performance on visual genome dataset is due to the existence of the objects with no relationship with other objects. Lastly, the figure shows qualitative results of the model. The top row shows the input scene graph to the model, and the second row shows the ground truth image. Looking at the last row, we can see that the RetrieveGAN model generates image of better quality, even with scenes with complex relationships. Link to the paper and some useful resources will be provided in the description. That's all for today, and I'll see you next time with a new paper.